Welcome to the session. Greeting of the day. In today's class, we are going to see about a few PLC programming, PLC ladder programming. In such a way, it will be more helpful for the design of the mechatronic systems and it will be helpful for the future trends. So, from basic level, PLC programming, we have to see how far it will be helpful for our trends. So that we are going to see. Now, I want to do some other actions like, you see, a device, a ladder diagram that could be used with the conveyor belt which is used to move a workpiece to a workstation. A presence of workpiece in the workstation is detected first by means of breaking the contact activated by a beam of light of the photosensor. So what I am doing, I have a system like this. In such a way, the component is going to come in between. This is the emitter and the detector. I have a photosensor here. Therefore, this photosensor is braked. It means the object comes in between. Here the laser light is passing. Some source of light rays is passing here. Emitter to collector. It is going in this direction. When object comes in between, it is going to break the source of light passing, and we understand that the object comes here and it is detected, the workpiece is available there in the tray. Likewise we understand. A detector. There the workpiece is stopped for 100 seconds. The workpiece is stopped for 100 seconds of time for an operation, maybe packaging, maybe drilling, turning, anything we consider. So it should be off, operation to be takes place for 100 seconds and operation to be carried out before the moving the on and off of the conveyor. The workpiece stops for 100 seconds for the operation to be carried out before the track has to be moved, before the moving on and off of the conveyor. For every 100 seconds, the operation to be stopped, the conveyor should be stopped for doing the secondary treatments. The motor of the conveyor belt is started by normally open start switch and stopped by a normally closed switch. When it is touched, it will on, and it is touched, it will going to off. Now what I am doing, you see, I have started, I have pressed, I have started, and S1, a photosensor which is going to detect the object from the conveyor belt. It is going to rotate. Object comes here, and therefore the sensor is detected. The sensor is available here, and at that side is the passage of current is going to detect. Object is detected. If the object is detected, it should stop for 100 seconds. It means we should stop the conveyor belt, we should stop. Motor of the belt, we should stop there. And then after 100 seconds, it should keep on move. If it is keep on moving, the second object which is available at this point, it will come to this location. And here the 100 seconds operation will do. So now, switch it on. Switch it on creates the contact. Switch it on creates the contact and the power rail, and power goes here. It stops and the motor is on. It means the motor is on here. Motor is first running. Conveyor belt is moving. Then only the object will come here. It is running. And I am latching this process. It should keep on running. It should keep on running. When it will stop, we will see. I have given when this S1 is detected. When this S1 is detected, you see, S1 is nothing but a photosensor. This photosensor is going to detect the object. When the object is detected, what should do? 100 seconds waiting time. Therefore, this S1 I have connected at this point, where I have connected motor earlier. After the motor should stop for 100 seconds. Then it can be able to start. After 100 seconds, we can be able to start. Therefore, this S1 is detected. I have connected this S1 to disconnect. So it is disconnected here. The circuit is S1 disconnect the power supply. Now again power supply came to here, motor not run, conveyor belt not moved. Because it is a brake on it is braked. We should draw this. Okay, and the contact is braked now. Contact is braked. Therefore it is brake contact happened. Now the operations keep on going. At the same time, how long it should go? You see, sensor S1 makes the brake contact for the motor to off, and also it started to give the connection to the timer. In such a way 100 seconds is started here. Operations is going, that is not in the ladder. Our initiation motor should start after 100 seconds. That is the program. In the meanwhile, the secondary operations of tool bit may come and do the object that we have not mentioned. That everything we have mentioned in terms of 100 seconds. In 100 seconds, the secondary operations will take place separately. That is separate program. So after 100 seconds, again the operation has been done. Operation has been over. Now the conveyor belt should start. It means motor should start and motor should move, and another second next process may come. So now the conveyor belt should start again. What I am doing? Here the timer is there. This timer, I am connecting this timer after S1, because this S1 is a sensor detected to stop. When the timer 100 seconds is completed, I am giving the input here at this after this connection. This output has been connected to the input of timer in the second run, and the second run has been interconnected to this point, and it is going. You see here, when the S1 is detected, the circuit is disconnected. But after the timer, the second power supply came here to the through timer after S1. This circuit has been disabled, and the timer is going to work here now. Now, I want to stop by normally switch. I want to stop by normally close the switch. Now with my self-interest, I am pressing the switch to off this. So when I am pressing there, what happens? This connection I am pressing, and it is going to break now. And circuit has been break. This circuit has been break. What happens? So therefore there is no contact between this here. Therefore again the motor has been finally switched off. So such a complex understandings we can able to do in the PLC programming. I am taking some other programs. You see here, a device a ladder diagram for control of a machine that is required to direct 6 tins on the path A for packaging in a box, then 12 tins along the path B for packaging on the another box. So this is the same sensor I have taken. If the object is detected, I want to send six objects. Maybe here by the program is mentioned as a tins. So therefore I want to send 6 tins in the path A in such a way I can able to make a box here for storing. Then after 6 is complete, I want to make this condition is closed in such a way this closing will come here. The path is closed. What happens? The tins which are all coming here, it will hit here and it automatically comes in this direction, and therefore the B will fill the 12. By the condition it is 12, and then it comes down, I can able to fill this 12 in this condition. So this is what my condition 2 I have to do. So how I can able to do here, you see, and then a spring return metal flap closes. A spring return metal flap closes. I have a spring return metal tap here in this point. So I have this spring return metal tap here. So this is the metal tap. This is a flip. It will be absorbed when here you see the coil I have. When it is energized due to magnetic field, it will absorb and this connection will come to this point. And then when this coil is energized, the coil B is energized. When the coil B is energized, this will come at this point. This is to be deactivated, and this is to be activated in such a way this coil will come this side. Therefore, the object can move in the A or object can move in the B at any direction with respect to the opening available. The trolley is same, track is same. I am controlling through the coil closing the opening. When it is closed, the object will go in the B. When B is closed, the object will go in the A. That it knows. But I have to count the sensors through this and the passing. It means the emitter here, 1 is detected, 2 is detected, 3 is detected. When the 1 is detected, at this condition to be there. So 1 it will go, 2 it will go, 3 it will go, 5, 6 it will go. After the 7th is detected, immediately coil B to be activated such a way it will come here. The 7th detected object will go here in this path. So here this emitter and detector, and then the coil we are going to use to operate. The spring-loaded metal flap in the path A and B is having two, and at the two paths, when a coil A in the path A is energized, the coil A in the path which is energized, in the path A, this one, when the coil A is energized, the flap is attracted and closes the path A, simultaneously when the coil B path, when the coil B, this one, when the coil B, if the coil B in the path B is energized, the flap is attracted to close the path B. So here the path will be closed. When the coil A is attracted, path A is closed. When the coil B is attracted, path B is closed. Therefore, when the coil B is closed, object will go through A. When the coil A is closed, object will go through coil B. The photosensor senses the number of tins. Here we came. The number of tins crossing the common path as shown. This is the common way. Here is the common way. If it is detected, A and B with respect to counts we should do. I have the diagram now. We have did the ladder program. You see, input it may detect emitter detector. So input here it comes, or input here it comes. It is going to detect. So it is detected by a counter. 6 counting it should be done. First I'm taking the chance, move the object to the A. Therefore, I have taken this path of counter 1 up to K6 it is keep on counting. K6 it is keep on counting. At counter 1 is activated. Now the 6 is went. It means this coil is in the attracted position at the 0th condition. It is closed here. Now what we have did here, the coil A should activate when the counter 1 K6 is completed. K6 is complete. Now the 6 object 1, 2, 3, 4, 5, 6 object is went here. In this path 6 object is went. Now I want to close this path. I want to energize the coil A. I want to energize this coil in such a way the flip flap will be comes and close this. So this counter 1 I am connecting to the output of coil A. So this coil A is this interconnected coil is A is connected. Here it goes, counts, and then it comes and our coil A is started to close. Now what happens? You see, it may be again input 1 or input 2. So whatever it is, either this one or this one, any one you can able to detect, and then it counts for 12. It is already closed. This condition is now it is attracted here. It is already closed, and then it is going to, this path is now diverted in this direction. Here it will count up to 1 to 12. Here it is detected 1 to 6. Now I am detecting 1 to 12 counts. After 12 counts is completed, I can able to stop. I can able to end. So that is how we can able to make the program. Somehow it is complicated, somehow we can able to easily understand. So such cases are possible through this PLC ladder programs. What happens here? Now I want to make this after K2. After K2, I including one more line. I'm including one more line, you see. Here, this counter 2. Counter 2 is connected to the coil B. So what happens? This coil will be energized. Therefore, this connection will comes here. And therefore, again the process sequence 1 to 6 is keep on moving in the other direction. It can able to continue. So such things are all possible. Next program we are moving to such a case that the device of a ladder, you see, a device of the ladder program that could be used to a domestic washing machine. I have taken a simple washing machine arrangement here such that a machine to switch on a pump to pump water for 100 seconds. First I am making a pump for 100 seconds into the machine, then it should switch off, then it can be disconnected. And switch on the heater and switch on a heater for 50 seconds and then heater should switch off, right? And then motor should switch on and then I am doing the motor should switch on, run the drum for 300 seconds and then it should turn it off. Now at last another pump should empty the water in the another, again the pump is on for 100 seconds and to empty the water. What we are doing, the washing operation we are doing. First water, a pump has been filled on the washing machine. Water has been filled first. This happens for 100 seconds. Then we are heating this water, warm water. The washing has been done on the warm water. So here the heater has been on and it is going to warm the water. So here it is now it is converted as a warm water now. How long it is warmed? For 50 seconds it is warmed now. And now we are putting the clothes inside physically and then the motor should be on for 300 seconds to spin in such a way we can able to washing can be completed. So it is rotating. So what happens? It is going to rotate for 300 seconds and it is off. And later you see at last this water to be drained out. Therefore here also one more pump I am using to drain out. So that will work for 100 seconds and it should off. So that is our program. You see now here. Now I have started to, we have as usual the power line and it is ready to attract when the power supply is given. That all it is. Okay. Now it is started. If it is started, first condition, the pump should on. So this is 1, 2, 3 and 4. So the how we can write here? 1, 2, 3, 4. So number 1 condition, pump should on for 100 seconds. So first I on the pump. The pump may run continuously. Therefore I have did the latching process also. Latching is done. Up to timer of 100 seconds. That is why I have made the break contact there. After 100 seconds it will break the pump. You see. The pump connection has been bent here, connection. And then the output has been taken here. And then it is going to connect. After T1, it means after 100 seconds, this I have taken as a T1. We can use T2, T3, T4. We are going to use. After T1, this connection is disconnected. This connection has been disconnected and therefore the power is not there, pump is terminated. So likewise it is stopped here. So what happens? So we are getting a termination here. A termination here, therefore it is disconnected. Now after this 100 seconds, it will disconnect here, break contact. Simultaneously it will activate the next run. Here the connection is activated. So what happens? It keep on running and it keep on running and it is on the heater. How long heater should run? For 50 seconds. Therefore, it is latching to be done because this is a timer. Maybe a push like contacts. Therefore, it is latching done. It just keep on running, and the heater is again it is connected here. And when the heater receives the circuit, it is connected, and then it keep on running for 50 seconds. It means a T2. 50 seconds. After T2, this is going to create contact in the next line. Simultaneously, it is going to create a contact, break the contact here. It is going to create the contact here. Therefore, heater also is terminated. It also is terminated. So what happens? Now, the second cycle also terminated, not available. Now, as per the second timer is switched on, it is giving the connection. It is giving the connection here to motor, because the third one is motor to run for 300 seconds for washing, for spinning. So motor is on now. That motor is output is given as an input here. So this is as usual, it is latching. So motor is connected. How long? Up to 300 seconds. This is motor 300 seconds I have given. Then it should off. After that pump should on. Therefore multiple connections. This T3 activated the next run, which goes to the pump. Simultaneously, it is going to disconnect this above connections. Therefore, the above connections we are not getting. It is terminated. Therefore, motor is going to off. Motor is going to off. This is not getting. We have terminated. Motor is switched off. So we have done this off, pump off, heater off, and the motor also off. Now secondary pump, which is releasing the water pump, we should on. So what happens now? You see, from the T3, the connection is to keep on going and on the pump. Pump 2. It is pump 1 for feeding. This pump 2 is for taking out. So pump 2 has been activated. We are keeping the latching, and then this pump should off when that is our program. Pump 2, after this pump 2 is activated, it should run for up to 100 seconds of time. After 100 seconds of time, this T4 has to disconnect here. Which one? The pump should stop. Final last pump 2 should stop there. So therefore, I have done the disconnection operation here. What happens? Therefore, the pump will not work. The pump will not work. This is going to disconnect. So this is disconnected like this. So disconnected like this, and the pump is not working. That is our program. We are understanding through a PLC simple ladder diagrams. So we can do such cases. The summary. In today's class regarding the PLC systems, we have seen about the contacts, about the ladder program, about the contacts, and about the brake contact, and about the relay coil, and about the timer, about the counters. So these things we have some with respect to advanced mechatronics approaches we have seen.